Evaluate the following definite integral. So for this integral, we have the integral from 0 to 1, 9x squared times e to the x to the third power dx. This is obviously a u-substitution. It's not a typical antiderivative rule problem. We have to pick a u and we have to pick a du. Let's talk about our choices here. Let me just write them up here. We have x squared, or 9x squared if you like. We have e to the x to the third is a choice. We have x to the third as a choice. Well, du for 9x squared is 18x. That isn't going to help me with the e, so that's out. The derivative of this is actually e to the x to the third times 3x squared. So in order for this to be my u, I would have to have two e expressions in my integral, which I don't, so it's not going to work. So therefore it looks like it's going to have to be x to the third. So let's go ahead and write x to the third right here. The du would be 3x squared dx. I see the x squared and I see the dx. Let me go ahead and divide by 3. So I end up with 1/3 times du is equal to x squared dx. I'm going to use this u and this 1/3 du. I'm going to go ahead and let myself know when x is 0, u is also 0 because I just plug it in. And when x is 1, well, great thing is u is also 1 because I just plug it in. So now I'm going to rewrite this definite integral, still going from 0 to 1. And then I see a 9, so I'll keep the 9 there, no problems. Let me go ahead and rewrite this above here, 9e to the x to the third x squared dx. Notice when I rewrite, all I'm doing is just moving, so commutative property. The e stays, but x to the third becomes u, and then x squared dx, that is 1/3 times du. So now let's clean this up. This is 3 on the outside from 0 to 1, e to the u du. Antiderivative rule, well, it's e, so its rule is it's himself. So we end up with 3 times e to the u evaluate it. 1 is 0. We'll plug the 1 in first. Remember, I went ahead and changed my limits of integration in terms of u, so I can go ahead and plug directly into the u. So this is 3 times e to the first power minus 3 times e to the 0th power. Well, we understand that e to the 0 is 1, so this is really just 3e minus 3. Of course, we can just pull out the 3. We could have did that from the beginning. And we end up with 3 times quantity e minus 1. So I like this problem because there was many choices to pick for u. And if you pick the wrong u, then you're not simplifying the integral. You're actually making it more complicated. So the reason we take our time picking the u and using our eraser if we pick the wrong u is because we're trying to simplify the integral. So then with a simplified integral, we can go directly into the antiderivative rules and then complete the problem. All right, thank you. Have a good day.